uh, it is the last month, I mean, in this semester, last data structure. Then the rest of them, it's related to graph, to other algorithm. I mean, following in the 3 weeks. But so it means that's very important. You understand this graph. Graph is actually, there is a graph theory, right? We will be use some kind of terminology using graph theory, vertex, then edge, right? So it's kind of the terminology actually is coming from graph theory. So graph is, graph is kind of very similar to the tree structure. You can think that this tree is one type of graph, right? You can think that this tree is one type of graph. So you graph can cover the tree, such kind of data structure. And then important is sometimes, but you talk about the trees, leaf is not being connected. But that's kind of narrow category of the graph. But when you talk about the graph, mostly they will be all of them possibly connect as well. So for example, even they can connect them in, especially if there is a tree also connect with the leaf, then also being called the type of the graph. Okay, so example that, for example, Twitter using the graph, Facebook using the graph, right? The difference is one is a direct graph, another is an indirect graph. What that means is indirect graph has both sides has direction, as you could call it the bidirectional. You can start from the one point to another point to the reverse. They can come to connect. But direct graph is only have a one direction without the backward shaking and chasing possibility. So it is a kind of you can think that this graph has a two category, basically big categories, indirect graph and direct graph, and then you can think that there is direct graph and the Facebook is indirect graph. Also think that the trees belong to one type of graph. That should be fine to general concept of the graph. And then you can think about from the computer perspective how we can represent the computer. And there is basically two types of presentation. One is using the two-dimensional array, which is being called matrix ageless. And then another is using the another is using the array plus linked list. Okay, it's being called adjacency list. Okay, so this is two kind of representation in the computer. Because whatever we take it, we have to use those things, then we can present it, then we can compute it. If you find some solution, we will be interested to say computer format, how we can represent this in the computer. So as you can say, so this is a second. If you think this is a graph, right? For example, this is a graph. 0 to 1, and then 1 to 2, 3, and then there is no any kind of didn't give any kind of direction, but nevertheless they have a example 0 has a two adjacency, two neighbors. I can call it 3 has 4 and 2, 1 has 0 and 2 has 1 and 3, such kind of relationship they have. But 0 and 2 and 3 and 1 is without any kind of relationship directly. So that's the kind of graph. Then let's see how we can such kind of, this is the adjacency list. This is a, oh no, it is a matrix age list. This is a adjacency list. I mean, as you can see, this is you can use two-dimensional array. Later on, I mean, I will tell you what is one, what is zero. As you can see, this is a kind of diagonal. No, the diagonal is zero, right? So the matrix, if you give the such kind of property, you know, in the computer, from the computer perspective, it's give a much more simplicity property, you know that, right? But we are not going to use it that way. But basically, that's from the, you know, if you're using the array, what does means is one is has relationship, zero without a relationship. That's it, right? So one, it means, for example, 0 to, I mean, 0 to 1 has 1, right? 1 has 1, and then 0 to 1, and then 0, 1 to 0, so 1, 2, 1, 2, 3, 4, 2, 3, 3 also. You can see that this is kind of symmetric, right? Symmetric relationship. So that's so far that should be interesting. Later on, how we can deal with that. If there's a unidirectional or directional, later we will be discuss it. So far that should be enough. I mean, this is a two-dimensional array. One thing that I'm not interested in is zero, because zero is any meaningless because without any relationship. But one is interesting, but that's the reason they have a little bit. You can think from this perspective that there is not advantage of zero still occupied the I mean position in the in the memory. So it is kind of wasting the space in the if you're using the matrix age list. But compare for that, adjacency list save the space. There is no any kind of extra space necessary to spend. But I mean, that's if you think that this is the this, or you can think that the node. Okay, so that's array. Call it array. Vector is also array, right? Later on we will use vector. This is a linked list. So this 0 has 2 neighbors, 1 has 0 and 2 neighbors, 2 has 1 neighbors. So kind of combination of the vector and the linked list, or you can call it the array plus linked list. But from computer to matrix H, you don't have I mean, there is a lot of space is wasted. We don't use the zero, but actually we used it. So that's one disadvantage. But maybe this is somebody think that this is very simple, right? Basically, the recommendation is when you use matrix ages, if there is a the adjacency, the relationship is well distributed. I mean, everywhere in that has a relationship, for example. Each of them has a link together, right? Each agency has a relationship. Then, I mean, most place should be well distributed to one. So that should be fine to use, using matrix ageless. But if it's not rare, I mean, it's very small kind of, I mean, there is one, I mean, less of the kind of relationship, then not recommended to use matrix ageless representation with the graph. So that's kind of two things so far you can able to see from the graph, right? From the high level, perspective. Okay, but let's do it by yourself. How you can create this? For example, I'm taking this paint. I mean, how about create by ourselves and increase the understanding, right? For example, let's say let's say later on we will be, I think I better to open it my VS Code later. Code. At the same time, I'm going to, for example, let's draw it. For example, 1, okay? This is 1, this is a 2, this is a 3, you can call it. This is a 4. And then you think that let's draw first the directional vertex. Okay, let's say 1 has 2 neighbors. Okay, but 3 does. Okay, I mean, let's say 3 does has kind of 1, but after that, let me think about it. Maybe we can link it between 3 and 4, but this is maybe end of is 3, or maybe you can end of is 4 also fine. Let's say this way, or maybe you can just remove this relationship. Okay, just remove this relationship. Just think that this is a kind of another kind of relationship. For example, let's say like this, right? That should be fine, right? I mean, how about that? If we use the, a matrix ageless, right? So it should be 4 by 4 matrix, right? You can create it 4 by 4 matrix. This is a 1. Okay, 4. 4. I mean, this is kind of node for this is 1, this is a 2, this is a 4. Doesn't matter. This is 3. Unnecessarily, you can have to be same. 1, 2, 3, and 4. This is a row, and I mean, kind of things that, for example, 0 to 0. It means you know any kind of meaningless. I mean, 0 between the. I mean, 1 to 2 has a relationship from 1 to relationship has 1, and then 1 to 3, no, 0, 1 to 4, 1, right? And the 2 to 1, 2 to 1, no relationship, right? From 2 to 1, no relationship. If I did like this, then had be doing like this should be fine. Assume that this has, I mean, right? So it's not possible to, some of them is unidirectional, some of them directional, so better to use consistently. So this is a 0, right? I mean 2, and then 2 from 2 to 2, this is definitely 0, and then 2 to 3 from also, this is 1, right? From 4 to 1, no, right? Because without any kind of relationship in the backside, right? But from 1 to 4 has a relationship, right? So 4 to from 4 to 2, from 4 to 2, they has a relationship 1, but others 0, right? For example, 3 and 4, and 4 and 4. This is also 0. This is the rest of them. 3 and 3, 3 and 2, 0, right? Because no any kind of backward direction. 3 and 1, no. That should be unidirectional, right? This is unidirectional. But if I doing the directional, they has a both side, right? If I did bidirectional, then what will be do is should be symmetrical, become the symmetrical matrix. This should be 1. Now that should be 1. That should be, which one is 1? Right, so it's symmetric. That's symmetric. That should be enough, right? Do anything? I left it. 1, 2, 3, 4. 1, 2, 3. There is one more. Which one? 1, 2, 1, 2, 1 to 1. 1 to 4, 1 to 4. Yep. 1 to 1 to 4. Right. This one. This one. So this is, and then this is. Now it should be fine, right? So if I using the unidirectional, that should be fine. Understandable, right? I mean, if I using the now second type of representation is the adjacent list. Adjacent list, we should be is one array, right? Plus linked list, right? For example, one has 2 and 4, 2 and 4. Okay, 2 has how do you think? Can you tell me? 2 has what kind of relationship? If I'm using the unidirectional, 2 has 3 relationship, right? Which is 1, 4, and 3, right? And then 3 has only 1, which is 2. And then 4 has 2, 1, and 2, right? So this is a two kind of representation. With one is this matrix age representation. Another is basically it's array. Second is vector plus linked list. Okay, this should be linked together, right? So it is embedded with it has a kind of link, right? Right. So basically this linked list, this is kind of things. Okay. So far should be concepts should be understandable. How we can do it with the in the code, right? So I wrote the here's I think I can start from adjacent list. Zero. That one, for example, I can create it like how does it look like? And this should be 0 to 0 to 1. Okay. 0 to 1. 0 to 2. 0 to 2. And then 1 to 2. 1 to 2. And then 1 to that's kind of they want to 1 to 2, 2 to 0. They trying to do it with the direction, right? So 0 to 1, that's one direction. 0 to 2, this is second direction. And then 1 to 2 is this kind of direction. 2 to 0, 2 to 0, that should be like this. 2 to 0, and the 2 to 3, and that should be like this. That 3 doesn't have any kind of relationship. 2 to 3, just like that, right? Okay, that should be fine. If you using I mean, this one is actually using the matrix representation. Why? Because in the graph here, you can think that this is a two-dimensional array, right? And then this is kind of number of dimension, right? So when you create this graph, actually this is initialization, right? So this is kind of matrix, but this is inside of the two loop. Finally, they created A and J. I mean, that's kind of at the first they created with the, false. I mean, this is kind of relationship, right? Uh, make the initialization, right? And then what's it? Adding the ages, age should be have to be with two link. One is a source, another destination, right? So it should I is the source, then J is the destination. So it means from the I, J, false, I, J, J and I's false. It means at the first, that's removing. That should be fine for me. I mean, that should be, there should be has add as well. Right, here's, I and J's and J and I. So it means it's a two directional, it's a undirectional. Huh? Okay, that's good. You should tell me. Now it's better now? Okay, so basically that's again, as you can see, this is a two-dimensional, right? Two-pointer is two-dimensional, right? So that's a kind of constructor, and then the constructor is, as you can see, this is a J and I. At the first is false. Fine. This edge is has to be two node linked together. So there should be must be source and destination. That's I's source and J's destination is I and J's first, J and I's. That's add I and J and I. Why? Because they have a two, both side has direction. If it's one direction, then I don't necessary to second line of the relationship. If it's directional, then I don't need the second one. But this is bidirectional, so it means that should be fine for to add this one. Now to strings, they trying to print out. This is a for inside of embedded another loop means they trying to access the I and J same time. So that's a kind of representation of the how the graph is printed. So okay, let's run it. Run it. Okay, that should be like just like this one, right? I mean, if I mean, you can see that this is a bidirectional, right? Zero, I mean, you can think that the zero is diagonal, then other is bidirectional, because if I'm just comment this one, for example, that should be becoming directional, right? Just save it, run again. All right. So now there's one more thing's interesting. Maybe there is wrong. I mean, what's wrong is actually this is wrong. There shouldn't be wrong. I mean, one to two. There should be 0. Man, you can say it is a line. This one and this one unnecessary. There should be one should be enough, because if you doing the add process, I mean, why? I mean, they automatically handle it with in the added process, because there should be same time added in both sides. So this is unnecessary. I mean, this one, this is unnecessary. This one definitely need to delete it. Okay. So it means now, as you can see, becoming, only then the upper side has, one, and the bottom doesn't have any one, because we commented, right? We commented this one. If I add it, I mean, there is a becoming the unidirectional, it means that bidirectional, right? They becoming like symmetric, right? One to one, I mean, becoming symmetric matrix, right? So, I mean, I cannot, maybe, yeah. You can say it. Okay, that's matrix representation, right? So that's one type of matrix representation. You can see that the graph has two-dimensional things, right? I mean, let's say the adjacency list. What that means is actually, as you can see, vector inside array. I mean, you can use linked list, that's fine. I can use the linked list like this. Link, I mean, list teaser, I mean, with like, give this one, no problem. It's also same, but I'm just, can use like this, also fine. I mean, no difference. One is in the inside the vector has an array. Another is inside vector has a linked list. No problem. I mean, that's another kind of representation with the array plus, array plus list or linked list. Okay. I mean, this is advantageous because they have a saved space, right? So assume that this is a 1 to 2. I mean, we can draw it, this relationship 1 and 4, 1 and 2, and then 2 and 3, 2 and 3, and 3 and 5. There should be 5. 3 and 5, and 4 and 5. I mean, that's the kind of representation, right? And then what's the, let's say that what's the edge, I mean, this is the source and the destination. You can think that this is a, array vector, right? Dynamic array. Push the D, right? So it means they has a link together. I mean, or D push the C, it's no difference, right? So they has a bidirectional, it means it has a bidirectional. And then what's the printout is actually for loop inside. This is nothing. It's they trying to print out this is a the element traverse all possible element. Let's run it. Okay. Hold on. It's not maybe I run it again, save it, and run it again. Okay. I mean, this is a kind of things. 1, 2, 1 has a 2 and 2 and 4 and 2, as you can see. 1, 4 and 2. 2 has 1 and 3. 3 has 2 and 5, 2 and 5. 4 has 1 to 5, 1 to 5. That should be enough, right? I mean, that's another kind of representation with the graph. I mean, so far we represented two types of representation. I mean, graph representation, two different types in the computer, right? Okay, that should be enough. Okay, we can take any graph to store in the computer, right? So that should be sufficient for now. Okay. Now people will be use it, right? So people use it, many algorithm. One of the algorithm being called BFS, first first search. BFS, you know, BFS will be explained in the next time. And the difference is, one is you know, they're using, for example, what's the you know, that should be start from the any vertex. Let's say this 2, right? Start from the any vertex, then they have a first they cover this level, then second, then they will be cover second level, then third level. That's, for example, I mean, 2 has they finish first neighbors, then coming to this top subnode, then also try to investigate they do have any kind of neighbors, then keep going to, you know, that's verse being called kind of, you know, handle first near the adjacency. What's the diff first searches, these they digging the, you know, deeply. What that means is they not going to care about what's the adjacency. They say, do you have any kind of link with another sublist? For example, the stuff from the root, they says, okay, I linked it with 2 linked to 3, and then 3 linked to 5. Then if there is no any kind of destination, then they will be stopped. Okay, that's kind of difference between the, you know, diff search first and first search and the diff search. But we will be explain the DFS in the next time. For this time, I will be explain the DFS, first search. Okay. Okay. Let's I know there is a code, but maybe we still have a time, so let's make it a little bit slower. So I just create new time. For example, let's call it the BFS, and BFS, let's say last one, or F, okay? Because there is a lot of BFS, maybe BFS2, or say CPP, okay? So I'm starting from the course. I have to use everything I need. STD, right? Using the INT main 0, okay. Now, okay. What I need is I needed to graph, and then the graph I'm trying to using the BFS. And then what's the BFS? Actually, they trying to start from the one node, then you know, print out all the nodes without repeating them. I mean, without repeat 2 times one node. That's just traverse all the node. Okay, that's the BFS. How we can do? First, we needed to graph, right? So first we need a graph, right? So we needed to define the graph. Second, we need a queue, right? We need a queue to traverse. Queue to use. What's queue? First in, first out, right? That's the two of them will be accomplished over the BFS search. So let's start define it. Let's say class graph being called graph. Okay. This is a graph will be they have to be has adjacency list, a relationship, and the one node has a relationship. For example, vertex we can represent the V. Okay. Then as well as we think that this is a we have to store the relationship to each node. So if you remember that we used the adjacency list, which is last time we used the list, we used the array, but now this time I'm going to use, for example, vector list, linked list. Okay, I'm going to use adjacency list. Okay, that's I'm going to use it. So that's graph. Okay, that should be fine. But I'm also going to provide some kind of function going to provide to access by the other class, right? For example, main needed to access. So there should be I must be give them publicly, because not only my class, maybe we can use it with the library if we provide with the other class, so should be fine. And must be has one that constructor, right? So I can give a constructor int vector int v, that should be fine. That's at the first I'm not going to implement the details, but at first complete whole construct, whole skeleton. Make sure we can understand. And that's defining the graph, right? Second is should be what's second? Yeah, second should be using the queue to implement the search. So let's call it there is nothing, then just print out. Okay, so I'm not going to return nothing, but I'm going to use call it. So that's void, and then let's give the name as BFS search. Okay, BFS search. Okay, that's called BFS search. But I need the BFS search. Actually, I needed to where I can start it. I have to give the one starting point. I call it the root, right? int root. So that should be enough for me. That's BFS algorithm search. That's fine. Okay, so far so good. And then I'm going to also I'm going to give a data. That data will be used sorted. So let's for example define the graph, right? The graph will be how much? Say 4. Okay, let's say 4 node. Then this is define the graph. Then I'm going to I have to, there is one more function should be is add add graph, right? In add graph should be I have to add it each node. I mean, I have to give a add edge. I mean, right? So add edge. This should be int. One is the source, another is the destination, right? So they will be nothing, then void. I mean, definitely they should be return one subgraph, but I'm not going to output it because I can directly share this the graph object. So that should be I'm not going. So that should be fine. Now what I'm doing here is um remember this should be like this. New should be hold on. Did I need this one? Okay. So G head okay, let's use the existing one, right? Let's use existing one. For example, this one, 0 to 1, 1 to 2. I mean, this one, maybe you can use which one? Let's use this one or this one. Okay, doesn't matter. Let's use it a little bit more. Oh, come on. Just okay, okay. Now should be fine. Now I'm going to just scroll up. That should be fine for okay. Now I mean 0, 0 to 1, G, and then uh 1 to I mean this should be 0 to 0 to 2, right? And then J 1 to 2, right? And J hold on, what to 2, and then 2 to 3, 2 to 3. That should be enough. 1 to 1 to 1. 0 to 1, 0 to 2, 0 to 2, 1 to 1 to 2, 1 to 2, 1 to 2, 2 to 3, right? That should be enough, right? Then I also needed to print out, of course, right? So I think, yeah, print out, maybe we can create, just print out inside of them. That should be fine. Now, I'm going to implement it, right? Okay, going to implement it. Just so what I need to implement it, I need to implement it. So this one first. That's point graph search the ints destination e. Okay. So what I need to do is I needed to adjacency list, right? Adjacency list to S to push back E, right? Adjacency list D to, because the B direction, if it is, it is a, that's kind of option that push back to S. I also can do this way. Just ignore the second one if I'm thinking that is one direction also. It's not be not too much. Just only one direction should be fine. This is one. Second one is should be void, definitely, or what being called the graph search, right? What I need is starting point and root. Let's call it the root. Is easier to understand. Okay. Okay. As I said, we needed to one queue, right? I'm using the queue to use list as queue, and let's say there is two things. One is two category. One is storing the whether they already been visit. If you visit, then I'm just never will be go back to access this node. So one, so that's I'm using one to using vector to store this visit state. So let's call it the vector to I'm using the boolean to whether access or not. So visit. Okay, so is it, okay, let's go away. And then second is queue. Okay, that's the queue is okay, that's queue, first in first out. Why is I'm using list? The C++ actually we can use the list is linked list. I can use list to represent queue, also stack, right? If I using the first in, make sure this is a kind of operation first in first out, then should be fine. For example, I'm inserting from one side, getting from the another side, that should be queue. If I'm get from the, I'm using the link, I only from the get from the one side, this is stack. So no difference. Depend on what you think in your mind, right? So that's a queue. And then inside, I'm going to no, that's they say what they say. They asking me. They're asking me the what trying to put it. Okay, I'm put it integer. That should be fine. Now first I'm root. I'm put it in the first. I'm accessing the queue. I put this in the queue. Okay. First I push back. Okay, push back to root. Okay, this is first stage, because later on I will be check it. This queue is empty or not. Make sure queue is not empty. While if queue is not empty, not queues empty. Queue is not empty. So that's the reason I put it something inside the queue. Okay. If it is not empty, then also it's not been visited. Okay. First of all, I think that okay, I have a. Do you have a? Do you have a neighbors, or you can say, do you have adjacency? So I needed also another loop to check it. Yeah, inside, if there is a loop being visited, then I'm going to push this to queue. Then next time I come here, of course, I needed to push back. Okay, first it's not empty, then I kick out. Okay, so that's a route. Okay, that's it. I'm using same time. I define second time route. Okay, that should be fine. Maybe I can use another name int in order to avoid confusion. Int with let's say a subroute. Okay, subroute to queue to what's the get back? I mean, if you remember, do you remember I push back, so I will be get back, right? And then also I will be kick back, so it's pop, right? Pop front, because I push the front, okay? So then I will be get this, they asking. Integer, this is integer. It's a void, right? Okay, fine. It's a void. Then first, I'm just there is not going to, they're not going to return me the value. So that's fine. That's fine. I'm just putting this. Make sure they accomplish the work. They kick out. But at the same time, it means no. Hold on. First, I'm get this value first. Okay, I get this value first, which is that you. Okay, let's say first. All right. Or use anything. It's the front. Okay, I remember there's a front, right? So I'm going to get the first, then kick out. Okay. Okay. Now also, I know this is subroute. I mean, I'm not sure there has another neighbors. So I needed to recursively check it, or I needed to iterate it. So I needed another loop for accessing this one. So I'm going to use a for. Okay, I'm using for to let's say the iteration. I mean, because inside, I remember inside has a you remember I used the list, right? So I can use iteration. So I'm defining the iteration first. Okay, let's say a list as a list iterator. Let's say 8. So I needed to 8 beginning to list. No. It's been called in the beginning. It's been called adjacency list, right? ADG list, right? ADG list. Okay, IDG list with hold on. It's a subroute. Subroute. as something iteration, then AT is not equal to end if they will be keep continuing. Adjacency list subroot. Okay. There should be end. It's not been end, then it should be mode pointer. Showing the pointer. Now there is something. Okay, that's a function, right? Subroot begin. All right. Begin function. This end is also function. Right? Okay, good. Now inside, what I'm doing is I'm checking. Do anything already in the queue or already been visit? I mean, visit is at the first I'm putting the by default is false. Make sure it's something been initialized. So visit at first, all of them is. If you remember, there should be. I'm defining the size because I already know the size, so should be v. Then it's the initialize with the false. Okay, that should be fine. No, so it means inside all of them false. Now I'm going to say if the also I remember I have to put this because I'm use root should be already been visit. I have to first put this visit. Okay, visit it as a root. First should be true because we already been accessed it, right? And then I can say that if is visit, I mean anything inside it, anything inside the IT iteration, but I have to give the pointer because pointer should be value, right? Then I need to push in the queue, push back the value, and then also give the mark is visit is true. It's interesting. Then it means okay. Let's again. So for example, I'm starting from the 2, right? Oh, maybe you can start from the 0, right? So 0 is first of all, okay, just I mean visit. Okay, this is a visiting list is 0. I mean there should be another queue, right? Queue. At the first I put this 0 and then this is visit, right? Then I needed to check it, do any kind of, I mean here's after that I needed to clean. Before that I needed to kick out, okay, and just kick out this one so it's not the first element. Then I need to check it, do any kind of sub neighbors. They have a 2 and a 1, right? So that's the reason 1 and 2 in the queue, which is that here's also been defined as true, so that's the reason 1 and 2 also is here. So then I'm coming here, okay, just say finish this 4, then come here, they what's the Q first? First element now is the 1. If you remember, I kick out this root zeros already before. Now I'm kick out the 1. Then I check it, do any kind of, I mean, that's also been kicked out, right? Do any kind of neighbors for 1? One say I have a 0 and 2, right? But do you visit? 1 is visit, 2 already been visit. So okay, that's then there's nothing I can do it. Then I'm come to 2. 2 say do any kind of neighbors? They say 1 and 0 and 1. Do you visit? Okay, you already been visit 1 and 0. So I'm not going to nothing, right? So now the 2 has a 1 neighbors, 3. So that's the reason I need to push back in the 3 here. Move this one and also make this visit 3 bin visit, right? Okay. So then ask 3, do you any kind of neighbors? No. I have a 2, of course, but this is bidirectional. That's fine. But if it is, we talked about if it is a bidirectional, depend on the edge. Edge edges now is 1, then should be fine. It is 2 is also fine. Then I'm going to consider 2 also they has a 2. Then D already been visit, so there's also been kick out. So there is an empty. It is empty. Then I can finish this while. That's it. So let's run it. Let's run it. Interesting. They say what they say. Undefined. Maybe something I file again, run again. Okay, just time. They say pushback. Function avoid graph back. What's the problem here? There is a give me too many argument in the function C. What too many argument? Any too many argument? It just run it without any kind of init. What does means int? What is undefined reference to graph and the graph? Graph is do you define graph? Oh, sorry, we didn't define the yet. All right, sorry. So I needed to define. Okay. Okay, graph. Graph. This is constructor. We forget this constructor int. Let's say where we. What we should do is here is we need to initialize this b to b. What else need to do? I think should be fine, right? Do I need to define vector? I think no. No, do I? Okay, let's run first. Because I'm using the vector, so should be no problem. There is didn't input nothing. Let me check it. Oh, of course. I didn't print out nothing. I'm going to. I think I should print out from here, right? Let's say cout. Cout what I say. Start from the root. Okay, so yes, let's say the stop. That should be fine. Come on. Oh, still didn't do nothing. I needed to delete it. What's the BFS2? BFS2 unique. Okay, I just deleted binary. Sure, I can generate it again. Hold on a second. What's the C out? C out. Found that you do anything? You found that this issues? Not empty. Okay, then here's just what's the problem? Do you think you have? Oh, come on. I didn't call the function yet, right? I didn't call the function. G search. I didn't. Let's see. Let's start from 0. Okay. We start from 0. Okay. Then run it. Come on. Maybe run again. Nothing. Let's just print out hello. See out. Yeah, they didn't print out nothing. So I'm just delete it again. Okay, just delete. Interesting. Why didn't print out hello? Maybe before that. I put this before that. They didn't compile. Didn't compile. Interesting. Okay, let's do it in the terminal. Okay, cd graph. Okay, then okay, let's delete it. All of the exe file. Make sure. Then G plus plus. Let's do it with even std plus plus 17. What else? I want my BFS2 CPP. Then object is BFS2. What's happening? Just did the inside terminology. Okay, open new terminology. CD graph. Of the exe. Now the time is 12:16, 12:16. Okay, I'm trying to run it. Yes, BFS to FSBS. Okay. Now allows outputting, but there is something wrong. What's wrong? Okay, just check my previous one. Okay. So what is my wrong? Where is my wrong? One of the things that I did here. Okay, maybe this one. Okay. They say I needed to initialize with this one. Okay, just fine. Size V. Okay, maybe. Okay, let's do it. Let's do it. Hello, 2. Okay, then here the exceed. Now the times. Okay, good. I'm going to run this one. 2 0 2 0. Okay, now let's, if it is the 2, if it is 0 and 2 and 0. Okay, if I am starting the, giving the post direction. Okay, then that should be, this is the S, and not the push. Okay, the push back, not the. Hold on. Also not good. 2 and 0. 2 and 0. 2 and 0. Which is not we expected. Which is not we expected. Difference. No difference. can tell me where I am wrong. Did you see my code? Where I am wrong? I think found it, then we can leave earlier. Let's do it. Let's do it. Should be push back, and then there is a pushback. Okay, then pop front pushback. Okay, in and end. Search and 0. Wow. Okay, let me just run this one. Okay, maybe run this one. Okay, that's correct. That's correct. Then I'm using, maybe I'm using the data source not correct. Just copying the data source is here. Okay. Starting from the 2, if should be, then should be same. Then okay, fine. Let's explain this one. That should be same. What we did here is right. Exactly same. So basically, I just want to recover again. The algorithm is actually BFS using the queue. Then they use the 2 things. One is the visit vector, which is trying to remember the who's been visited, right? So if it is been visited, of course, at the first I have to put this the root, right? Then inside I needed to use this whether empty. Then if it is not empty, then I keep going to digging the neighbors. If the neighbors is existed, of course, then it means going to access this one. Then also this neighbors already been inside the visit list. Then I'm going to not inside. Then I'm going to push back. Then as well as to make it this true, already been visited. The next time they coming, they will be pop out. They will be pop out, right? So they will should be, yeah, that's all about this algorithm in the using the BFS. Actually, they're using the BFS. That's it. Going to stop it. That should be end of the lesson.